Today we are going to find the moments of inertia of a three-dimensional solid. With this formula given, we can find the inertia of a three-dimensional solid by triple integrating r squared with the density function along x with respect to x, y, and z. So to find the inertia along x-axis, we can triple integrate y squared plus z squared, multiplying the density function and integrating it with respect to x, y, and z. Similarly, if we want to find the inertia along y-axis, we can triple integrate the function x squared but plus z squared, omitting y and multiplying the density function again and integrate it with respect to x, y, and z. And for the z-axis, inertia of z along the z-axis, similarly, we triple integrate the function x squared plus y squared, omitting z and multiplying the density function and integrating it again with respect to x, y, and z. And if the limit given is the same throughout inertia of x along x-axis, inertia along y-axis, and inertia along z-axis, the answer come up will be the same for each one of them.
Now we are going to look at example. When you are given the density function x plus y plus z is equals to 1, and we are told to find the inertia in respect to x, y, and z of a solid cube in the first octant bounded by the coordinate plane and by x is equals to 1, y is equals to 1, and z is equals to 1. So that's the cube will be in this shape. So x will be 1, y will be 1, and z will be 1. So when you are told to find the density, when you are told to find the inertia in respect to x, we take the formula. There is a formula given y plus z squared times the density function. So since the limit is from 0 to 1, we are going to get the inertia in respect to x. So we are going to double integrate the density function, then multiply it by the y squared plus z squared. So first we are going to multiply this function times this one. So then we are going to get y squared x, y cubed, y squared z, y squared z squared x, then we get z squared y plus z cubed plus z x dx dy dx. First we integrate it in respect to x. So we will get this function. Then the limit is from 0 to 1 dy dx. Then after integrating it in respect to x, we solve, you can see here, then we subtract the 0. The next stage is we integrate it in respect to dy. So that's when we have y squared, y cubed over 6, y power 4 over 4, y cubed z, and then the limit is from 0 to 1 dz. After that, then we solve, and we are left with the last part of integration, which is in respect to z. So we integrate this function in respect to z. Then the final part, when we have integrated everything, now we subtract. So we subtract the function and we are left with 11 over 6. Since the limit is the same, 0 to 1 in respect to x, and 0 to 1 in respect to y, and 0 to 1 in respect to z, we don't have to find the inertia in respect to y and z, since they are all equal. So the answer will be 16.